Okay, so good afternoon everyone. I bring you a tutorial today on SURDS. It's an introduction to SURDS, and I hope you'll be able to learn something. So to those of you that have not yet subscribed to my YouTube channel, make sure that you subscribe, and if you have any question concerning what I'm going to teach, make sure that you WhatsApp me on this line here. So what is a SURD? A SURD is a square or an nth root number that cannot be expressed as a rational number, that is, as a quotient of integers. In other words, a number that cannot be expressed in the form a over b. Okay, so that is a SURD. So now, for example, we may have square root 2, you may have square root 3, you may have square root of 7, you may have cube root of 42, etc. All these numbers are said to be SURDs because they cannot be expressed in the form a over some b. Now, there are certain rules that you are supposed to know on this topic. The first rule is simply what we're calling as the product rule. The second one is called the quotient rule. The third one is called the sum rule. Now, for the product rule simply states that for the square root of a multiplied by the square root of b, this can also be written as the square root of a multiplied by b inside. For the quotient rule, it simply states that for the square root of a divided by square root of b, this can also be written as the square root of a divided by the square root of b, which is equal to the square root everything, then a over b. Okay? Now we can also have the sum or the subtraction rule, which simply states that for any value c of the square root of a plus or negative, then you have also some value d, the square root of a. This can also be written as c plus or minus d, the square root of a. So what we're simply saying is you can add these two or you can subtract these two and simply maintain the square root of a like that. Okay? Now, I'm going to teach you how to apply these rules over these questions. So now the first question is simply saying, simplify the following sets using the above rule. Simplify the following sets using the above rule. So for the first one, we have been taught that we have the square root of 8 multiplied by 2 like this. According to the rule of multiplication, this can also be written as 8 multiplied by 2 like this. Then this can also be written as 16. Then the answer is 4 like that. Okay, it's a very simple topic. For B, they are saying that the square root of 78 over the square root of 6 like this. Now this can also be written as the square root of 78 over 6 like this. Okay, so if you make a division there, you discover that your answer is 13. So not even forgetting the root of 13 like this. Okay, so it's a very simple thing there. It's a very simple thing. It's a very simple concept. For C, we can use the sum or subtraction rule, where we'll just assume that just the same way you solve those questions where you say this is 11x, this is 4x, we will maintain the square roots and simply subtract these two. So what is 11 minus 4? You simply get 7. Then you maintain the root of 5 like this. Okay? So for this one, you are done. Okay. Done like that. Then we come to 2. For 2, they are saying that we simplify the following as much as possible. Okay, so I'm going to do this very fast and quickly so that at least we are done. Now, if you have the root of 27, Now, to simplify this, we know that the root of 27 can also be written as 3 multiplied by 9 like this. Because if you combine this, it's 27, right? But then we know that this can also be written as the root of 3 multiplied by 3. Because we know that the square root of 9 is 3. So this can also be written as 3 root of 3 in this manner. So you're done. We come to B. The same concept applies. Okay? We know that the square root of 12 can also be written as the root of 4 multiplied by the root of 3, like this. Is it true? Yes. We know that the root of 4 can also be written as 2 multiplied by root 3, like this. Now this can also be written as 2 root 3, like this. Very simple. We come to this question. C. They're saying the root of 512 minus 15 root of 2. Okay, how do you solve this one? Now we know that this can be broken down into the root of 2 multiplied by the root of 256, like this, minus 15 root of 2. Okay? It's just one and the same, right? Just one and the same thing. Now when we reach here, we know that this is a common square. In other words, we can find the square root of this. So we can find the square root of this. What's the square root of this? It is simply 16, right? Minus 15, then 2, like this. Now from here, we know that this multiplied by this is simply 16 root of 2 minus 15, then 2. Now, check what's happened here. We can use the sum or subtraction rule because we know that this is 16, this is 15, and this are maintained. Therefore, we can say 16 minus 15 is just root of 2, like this. So for those of you that are following this channel, I want you to solve this one. Make sure that when you solve this one, you send it on the WhatsApp line so that I'll be able to mark you. In my next tutorial, I'll be teaching you how to rationalize sets, and hope you'll be able to learn something. Thank you so much.